All right, juniors, here we go. 4-5, graphs of sine and cosine. I'm only going to go through a little bit of this with you today. Little bit of this, okay? Here is the overview of what we did yesterday. We wrote this on your unit circle. Here is the graph of the sine function. This is y equals sine of x. Remember this, okay? Remember this. He starts down at 0, then he goes up to 1, then he's back down at 0, down at -1, back up to 0, and this is one full period of y equals sine of x, okay? When does he stop and come back to 0? When does his period end? At 2 pi, like one full circle, right? The unit circle is 2 pi. One full circle is 2 pi. In the middle, what's halfway between 0 and 2 pi? Pi. So he is there at pi, right? This guy would be pi over 2, and this guy is 3 pi over 2 where he's high and low. Got it? That is the graph of sine, yeah? Get that stuck in your brain. Down, up, down, up. Okay, that little wave right there, okay? The graph of cosine looks like this. He is similar. One period of cosine goes from 0 to 2 pi again, pi in the middle. 3 pi over, or pi over 2 and 3 pi over 2 are my other two places, but he starts up at 1, down to 0, down to -1, up to 0, up to +1. That's what cosine looks like until we change him.
Don't do that.
Okay, ready? All right, here in just a tad bit, we're going to learn what all this stuff means. So write this down. Y equals A sine of bx minus c plus d. We're going to learn what all of this junk means. Okay?
Wait, did you say
write it down or don't
write it down? Also, y equals a cosine of bx minus c plus d. Okay, we've got all those guys. Write those two down on your front sheet. Nope, 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 nope. These are graphs of curves when we do stuff to them, like to move them around, okay? So we can insert numbers in here. There's 4 different things that I can do to the function. I could have a number here for a, actually 5 things. 5 things. A number there for A, I could put a number in here for B, I could put a number in here for C, a number in here for D, and doing those things will move them around. Now, I hopefully won't give you too many problems where you have all 4 or all 5, technically, things going on at the same time, right?
Can we determine if it's, what letter it is?
Yes, I'm going to tell you what those are here in a second. Okay, now I only circled 4 letters, A, B, C, D. What's the 5th thing that we can do to him? Any guesses?
Plus and minus.
Plus and minus. So I could put a minus out in front, and this is going to reflect him. So maybe put like a little thing up there like, hey, we can do that too. Okay? So we can insert all sorts of different numbers into his formula, and we could add a minus sign out in front. All right, we're going to learn these bit by bit. So today...
Would the C change?
Yeah, what?
Could you make
No,
Wait, which
we'll talk about that.
Which
Okay?
axis would that flip?
Over the x. So this guy, write this down. This guy goes over the x-axis. If we have a negative there, he flips over the x-axis. Are you writing this down?
Yes.
Over the x-axis. This A changes the amplitude. Okay? Do you know what amplitude does?
This is literally Mr. Moves. This is...
Amplitude. What is amplitude?
How far from
Yeah,
rest?
this is like the height. The height of your curves, okay? This is a vertical stretch, in other words. Vertical stretch or vertical compression. We could vertical compress too, okay? Vertical stretch or vertical compression. It changes the amplitude, okay? All right, the B value has to do with the period. So normally the period for sine and cosine is how much?
2 pi.
2 pi, but I can change the period. I can make him skinnier or fatter by changing the period, okay? So this is like a horizontal stretch or a horizontal compression, right? Changing the period, all right? Now this guy is going to move him to the left or to the right. This is something called a phase shift. We won't get to this today, but I'm just telling you what this stuff is, the phase shift. And then if there is a number here, what do you think that one does?
Up and down.
Up and down, that's a vertical shift.
Hang on.
Okay?
Memento.
Vertical shift.
C is left, right?
C is left or right, that's called a phase shift. And then a vertical shift up or down is what D does, okay? We are only going to probably get to A and B today. Amplitude, period. We're changing amplitude and period, and that is all, okay? Now, you're going to have to graph some of these curves changing the amplitude period, all this stuff. And I do give you some where you have all 4 things that are changing. Those can get to be a little difficult, all right? So you really have to be careful of how you're graphing your stuff. But I will hopefully give you baby steps to figure out how this goes. Now, it doesn't matter if you're graphing sine or cosine. All of those numbers are going to mean the same thing, right? A, B, C, D does the same thing for sine as it does for cosine. It's just sine goes like this versus cosine goes like this, right? That's the difference between sine and cosine. Okay? It just tells you what your first function looks like. All right? All of that stuff. Okay? Time to get out of here.
C always minus.
47. C is always minus, and I'll show you why later. Later, not today. I'll tell you why C is minus later. Because, okay, here's why C is minus. Left or right, plus means left, minus means right. That's why he's minus. Does that make sense? Right? If you have something inside of parentheses and I say, is he going left or right? You're like, plus. Plus means left, minus means right. It's the opposite of the way that you think, right? That's why C is minus. Okay, there you go.
Can you just go over a little bit?
I can't. This way?
What's the vertical?
Vertical shift.
Up and down.
Vertical shift, up and down. Yep.
Okay, now you're good.
That's what he is. Okay, let's experiment. Go to the next page. We've already blown through all of this stuff. Example 1. We're going to graph. What? Okay, here is this guy. He is very short. Normally he was sine of x, but this guy is my A value. This is the value of A, which means my amplitude is 3. The amplitude is 3. We're going to graph what that looks like here in just a second. Now, everybody listen to this. Are you listening?
Are you recording?
B. Yes, I am. B. Listen to this because I am going to be picky about this when it comes test time. What is the amplitude for B?
Half. Negative, no, half.
2.
I'm going to say it's half.
-2.
It is half. It is not -1/2. Amplitude talks about the height of something, right? You can't have a height that's negative, okay? The negative is going to flip him, but your amplitude is never negative. Amplitude is talking about distance. So please make sure your amplitude is always a positive number. Don't look at this negative when you go to determine amplitude. Got it? The negative is going to flip him. All right, so let's talk about sine. All right, we're going to graph our first sine function. Here he is, okay? I'm going to take... If you guys have 2 different colors, this is not a bad idea to graph in 2 different colors. I'm going to graph him in 2 different colors. If you want to graph just the ending one, you do you. But here you go. We need a 1 and we need a -1. And the 5 markings on the x-axis. Are you watching? This is idiot proof how to graph sine and cosine. I'm going to try to make this idiot proof. You start here at 0. You end at 2 pi. What goes in the middle? 1 pi. What goes in between there?
Half a pi.
Pi over 2. What goes right here? 3 pi over 2. Okay, I make this idiot proof. You have those 5 markings on the x-axis. I'll give you a second to write those down. Okay? You have those 5 markings on the x-axis. 0, pi over 2, pi, 3 over pi over 2, 3 pi over 2, and 2 pi. Those are your 5 places. Okay? Then we're literally going to draw dots.
1, 2, 3, 4 on the X. Not on the
Yep. 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 Yep.
Never mind. I wrote it wrong.
I should have made this shorter, but that's okay. Can I change this?
No.
I'm going to make this 3 and this -3. And then I'm going to do like this. Because otherwise I'm up too high.
Okay.
Can I do that?
Then stop for a second. You gotta give me a second.
Okay, change your 1s to be 3s. Sorry. Otherwise I'm going to be way too tall. I'm just going to change my markings because I can do that. All right. Sine. Where does sine start?
At
0.
At 0. Okay. And then he goes up to
3.
1. Then he goes down to 0. Then he goes down to -1. Then he goes back up to 0. This is what just, hold on.
We should graph
This is what just sine of x looks like.
Should graph this or don't graph this?
I don't care. You can graph it. I always graph the original. This is what just sine of x looks like. Okay? They didn't want us to graph sine of x. They want us to graph 3 sine of x, but I always graph the original guy on there so that I can see what he looks like, okay, in comparison. All right? The difference is he starts at still 0, but he goes up to 3, down to 0, down to -3, back up to 0. So there is what he looks like. This is 3 sine of x. That's what the amplitude does. Now, people get this confused a lot because amplitude, they're like, okay, amplitude is 3, but hold up. The distance from the high point to the low point is actually how far? 6. Don't confuse that. Your amplitude is only from center up or center down. It's from the midline up or midline down. So the whole thing is actually covering 6 units, right? When your amplitude is 3. Got it? Okay. All right. Now let's talk B. Boop, boop, boop. Okay. This one is the graph of cosine. Pay attention which parent function you're talking about. So I'm going to make 1 here. I'm going to make -1 here. You still use your same units.
So we start
0.
at -1 instead
2
of
pi.
starting at
You
1.
betcha. You betcha.
Yeah.
0, 2 pi. Pi goes here in the middle. Pi over 2. And 3 pi over
Actually, no,
2.
he starts at half. -half.
Yes, 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 yes.
Do you have a stamp for this?
A stamp?
Yeah.
No,
That'd be a nice stamp.
no.
We need to get you one.
Here, when we get into it, I'll just label pi and 2 pi. I won't label these other two because I get lazy. But for right now, we'll do this. Okay? All right, cosine starts at 1. He goes down and up and up. I make my 5 dots. I'll tell you that all the time. Make your 5 dots. Where are your 5 dots located? Then connect your dots. Whoop, and make them little curvy things. Right? So he looks like that. That's what normal cosine looks like. All right, now we're incorporating 2 things in here. One is the amplitude change. He is now half and he's negative, which means where's he going to start? Like where will 0 be?
-0 or -1.
-half.
He'll be at -1, but he'll be at -half because he's half as tall, right? So he will start here. He will go up to here, up to half, down to here, down to half. So this is what he will look like now. Do you see the difference? Notice that he still crosses at 0. Wherever he was crossing 0, he's still going to cross at 0. Got it?
Got it, got it.
Got it, got it? Okay, but that is negative and half. The amplitude is shorter. We're making him shorter and negative. Got it?
He doesn't really look shorter.
What?
He doesn't really look much
Doesn't
shorter.
have as big of a belly.
Yeah, but like,
I don't know.
Right, right. Yeah, exactly. Yeah, yeah. He's a little bit, whatever. Okay? Good?
he's not as drastic as the first
Right,
one.
exactly. Yep. Okay, good. That is amplitude. Amplitude's easy. Should be easy. Some of this is easy. The hardest one of the 4 to learn is
B.
C. C is the hardest. A and D are the easiest. Vertical shift and amplitude, those are the easiest. Period is like just a baby step harder than that, and then phase shift can get a little ugly. Putting all 5 together is really kind of a little bit ugly sometimes,
Are we
okay?
have to do that on test?
Maybe. We'll see. I don't know. Okay, all right, go down to example 2. All right, this is the last thing that we're going to learn, and then we'll stop. We'll do example 2 and maybe example 3, and then we'll stop. Okay, this is all talking about period. So they have changed our amplitude. What's our amplitude, by the way? Amplitude is now 4, so he's 4 tall and 4 low, so 8 altogether, right? Amplitude is 4. And then we have something called the period. And the number that's right in front of the x is what is going to change the period, okay? And period is how long it is from start to finish. Like basically it's one chunk of it before it starts to copy paste, right? That's what a period is, okay? So period is 3x. Now,
Why is it?
Are you
not just
listening?
3?
what?
What? Can we just say B is 3?
Okay, so your B value in this case is 3. Like A is 4, B is 3. Got it? Your period. Amplitude is just the number. Amplitude is just A, but the period you have to do like a little baby formula to find the period, right? What's the normal period of sine? Like how big is
2 pi.
sine normally? 2 pi. So in order to find period, the formula for finding period, circle it right up above here, is 2 pi divided by B. That's it. 2 pi divided by B.
No, 2 pi thirds.
2 pi divided by B. So if my B value is 3, the period is 2 pi over 3. Okay, so hold up. He was 2 pi before and now he's 2 pi over 3. Have I made him wider or skinnier? Skinnier, right? 2 pi over 3 is smaller than 2 pi, right? So the deal here is if this number is a whole number bigger than 1, numbers bigger than 1 are going to make him skinnier. If this was like 1/2, right? 2 pi divided by 1/2, I would keep flip that. So he'd be 2 pi times 2 over 1. He would be 4 pi. Numbers that are smaller than 1 or like fractions are going to make him wider, right? It's like the opposite, yeah? Okay, so fractions or numbers smaller than 1 are going to make him wider. Numbers bigger than 1, like 3, are going to make him skinnier, yeah? So here we go. Let's answer the questions. We haven't even got to the questions yet. Identify the amplitude and period. We did that right here. We already did that. Whoop. Okay, graph the function and identify the key points on one full period. The key points just mean those 5 points, right? We outlined what those 5 points are. All right, so I'm going to make this like here. And we need to go up to 4 and down to -4. Up to 4, down to -4. Okay, so what I'm going to do is rather than graphing just sine of x, I'm going to graph 4 sine of x, right, as my like original guy. And you don't have to grab the original guy at all. I'm going to go 2 pi here. I'm going to go pi here. I'm going to go pi over 2, 3 pi over 2. So I'm just going to put those little dashes, and then I've got 0 here, okay? So we are doing sine or cosine, which one? Sine. Where does sine start? Sine starts at 0, and then he goes up to 4, down to 0, down to -1, or -4, up to, so this is what normal sine looks like. Normal sine. Actually, this is normal 4 sine, right? We just graphed 4 sine of x. That's what we graphed, okay? Now, I'm making the period 2 pi over 3. Okay? 2 pi over 3. All right, where in the heck does 2 pi over 3 live?
Between.
Like, if I start him at 0, he's going to end at 2 pi over 3. Where does 2 pi over 3 live?
120 degrees. So in the second quadrant.
Uh-huh. This is the first quadrant. This is the second quadrant. This is the third quadrant. This is the fourth quadrant. True?
So a little
Like
bit
if you're thinking
past
about it in
the
terms of that?
second guy.
Okay, so think of this. This is 3 pi over 3, right? That's what pi is, right? So I want 2 pi over 3. So imagine that I like section this off into chunks, right? 1 pi over 3, 2 pi over 3, 3 pi over 3. Do you see that? This guy will be pi over 3. This guy will be 2 pi over 3. And then I have 3 pi over 3 where like 1 is, right? Okay, I'm going to erase this guy. So we are going to stop him at 2 pi over 3.
Oh goodness.
Oh, goodness.
Oh goodness.
Right?
Oh really good.
So,
Pause for a second.
okay, I'm paused.
3 pi over 3.
Okay, go.
Okay.
No.
Will he still start at 0? Will he still start at 0?
Yes.
Yep. Where is he going to be up at 4?
Like really.
Like
fast.
here, like in between there, right? Then he will go back down to 0 at pi over 3. Then at the halvesy point, which is actually pi over 2,
He made it.
he's going down there. And then back up to there. And so this is what the curve looks like.
Just really.
So I made him tall, right? Taller than he was originally, original sign. He's 4 tall and 4 short. And now he's narrow.
Why
Right.
didn't we go all the way to 3 pi over 3?
No, I just went to 2 pi over 3
But why?
because that's what the period is.
Oh, it just ends there.
It ends at 2 pi over 3. Yeah, I just said that was 3 pi over 3 so you could get an idea of where you section him, right? Okay, you got it? Make sense? Ish, a little bit? Not too bad? All right, let's do another one and then we'll stop. This one is graphing cosine. Oh, I don't want to do that. I don't want to do that yet. Can we change this? And I'm going to get rid of the plus pi over 2 because I don't want you to do that. Let's just graph cosine of 2x. That's all. Graph cosine of 2x. Get rid of the pi over 2. Okay? So our amplitude. Ooh, if we don't have a number, what's the amplitude?
Probably 1.
1. He stays 1 because he's 1 tall and 1 short. Now the period. How do you find period again?
2x.
2
So
pi
it's
over
2 pi.
2 pi divided by b. What's the b? 2. What's 2 pi divided by 2?
Pi.
Just pi. So the period is now pi. So he is half the length of what he was before, right? Okay? So amplitude period up here. Okay, let's graph our key things, all right? And I always like to graph the original. We're going 1 tall and 1 short. Okay? I'm going to go 2 pi here. I'm going to go 1 pi here. Pi over 2, 3 pi over 2. Got it. He starts at 0. No, he doesn't. This is cosine. We're starting up at 1. Then we go down. Then we go down. Then we come up. Cosine like makes a V with your dots, by the way. But then don't make him a V. Make him curvy. Like that. Okay? Good? That's what normal just cosine of x looks like. But now we're going to make him shorter. right? Like
He's just gonna
skinnier, right? So instead his period is going to be pi. So that means he's going to start here and he's going to go here. It's like I've taken him and I smushed him, right?
So just a V inside
Doop,
there.
right there. So make your 5 points. Is he still going to start at 1?
Yes.
You betcha.
He just
Okay.
can go back.
Let's
in
make my
between
5 markings. So he starts at 1 and he's going to end up here at 1, right?
So,
Okay.
What would it be? Would it be 4 pi?
I'm going
Half
to
will be down.
chunk him into pieces, right?
He'll be down.
At half he'll be down, here he'll be there, there he'll be there. He's making like a V, right? But I'm going to make him a curvy V, and he goes like this. Whoop, just like that, okay? That is cosine of 2x instead of cosine of 1x. Yeah? Ish. Do we see how this works? That's not too bad. Amplitude period. We got him. Good.
Stop.
Yeah? What happens if they would have said negative cosine of 2x?
We would have.
Do you know what he would look like instead? He would have gone like this instead. That's what he would have looked like. But he's going to go through that.
DNA genes, guys, or no?
Right, kind of, yeah,
No.
exactly,
So
yeah.
What is it called?
Yeah.
Something helix. Is it a
Triple double helix, whatever it is, right? Yeah. So anyway, that's what negative will do. Okay? Good? All right. You might be able to do the first couple. The first couple questions on the homework are just asking for like, I think, just asking for amplitude and period. Mhm. They're just asking for amplitude period and not asking you to graph it also, I don't think. So you can get started on some of them. Okay? All right. Good work today. Very, very nice.